Hello. Today I present our work ARDIAS, which stands for AI Enhanced Research Management Discovery and Advisory System. I am Debayan Banerjee and these are my colleagues, and we are from the University of Hamburg in Germany. The objectives of this project are to build a repository of scholarly data consisting of authors, publications, and venues, and to provide a user interface for the search and discovery of topics of interest. Here is an introduction to the web interface, which we will describe in later slides. As we can see, there is a search bar on top where you can search for works, authors, and venues. And in the bottom, you can see in detail the name of the paper, the authors, the year of publication, the venue, and an abstract of the paper itself. As the underlying database, we use a snapshot taken from the website openalex.org. Openalex.org maintains a database of 200 million nodes, where nodes are divided in 4 broad categories called authors, works, venues, and institutions. The architecture of ARDIAS is as shown here. The ARDIAS has primarily 4 components, that is discovery, recommendation, collaboration, and communication. We take a dump from the OpenAlex and store it in an Elasticsearch instance for free text search. We also pre-process the dump and store it in a graph structure in a Neo4j graph database. The web API is built in Flask, and the elements of the web API and the interface are hosted using Docker containers. At this moment, we have only developed the discovery elements of ARDIAS. The recommendation, collaboration, and communication aspects are to be developed in the future. Here is the master search page of ARDIAS. As we can see, we can search based on 4 different criteria: works, authors, institutions, and venues. Here are 4 options that you can use to log in into ARDIAS. You can use your full name, your institute affiliation, your org ID, or OpenAlex ID. Once you look for the name of an author on ARDIAS, as a drop-down menu, ARDIAS provides you with an option of several names that you can choose to disambiguate the choice of names presented to you. Once you have selected the correct author, the author display page looks like this. Once the display is populated, you can further sort the display using a couple of different criteria. This is the co-author network for the author Debayan Banerjee. As you can see, the co-authors of Debayan Banerjee is shown in a graph structure. You can further double-click on one of the co-authors. For example, once you double-click on Jens Lehmann, the graph further expands and Jens Lehmann's co-authors are also shown. Here is the UI for the research focus of a given author, which is shown as heat maps. Another interesting feature of ARDIAS is, since we store the OpenAlex dump in a graph structure, it is possible to run algorithms such as shortest path between 2 nodes. For example, here we see that the shortest path between Debayan Banerjee and Geoffrey Hinton exists through 2 authors, Jürgen Gall and Gerard Ponsmol. This feature can be useful in the future for the communication aspect. Let's say a particular author wants to get in touch with another author and wants to find out if there are any common co-authors who know both. At the moment, only user-led discovery is implemented. That is, the user looking for things that the user already knows about can search for them and browse. AI-based recommendation and discovery is still work in progress. Communication and collaboration tools are on the roadmap. Thank you for your attention and kindly read our paper in the link below.